started. Again, page 250. So today, happy Monday. This is our very last lesson of new material for the entire semester. I promised myself I wouldn't cry. Today we're going to talk about equations involving algebraic fractions. The answers to questions in the last three classes were expressions like x plus 5 over x minus 2. Today the answers are going to be numbers, x equals 17, x equals -4. Okay, we're solving equations today. Coming up on Wednesday is our fifth and final quest. It is on 27 through 30, which is all of the fraction stuff, including today. Coming up on Friday, and then also a week from today, Monday, are review days for the test, the final exam, I should say, which is a week from Wednesday. Any questions on any of that? Don't remember if I said this on Friday, but it is definitely not too early to start studying for that final exam. We've covered a lot of material this semester, and it is much better to study, say, 20 minutes a day every day for the next 9 days than to cram on the night before the final exam. Cramming is bad. So see if you can budget your time, probably not just for this class, but for all your classes. Space out your studying. Don't cram. All right, so let's take a look at the very last lesson, page 215. In this lesson, we solve equations that include algebraic fractions. All right, so let's just jump in to the problem, and I'll explain what we're doing here. So here's the equation we're going to solve. 2 plus 4 over x minus 2 equals 8 over x squared minus 2x. Looking for a value of x that makes that equation true. Again, for the first time in 4 classes now, we have an equation. Everything we've been doing in the last 3 classes was expressions. Okay, so here's the technique. We are going to factor all of the denominators. The first fraction, well, it's just a 2, and the denominator is 1. There's nothing to do there. The second fraction, the denominator is x minus 2. We can't factor anything there. But in the third fraction, we can factor. And again, our ordering is always the same. Greatest common factor, difference of 2 squares, finally the box. What is the greatest common factor in this last denominator? It's x. And so when you pull x out, you're left with x minus 2. Yes? Okay, so all I've done is taken this thing right here and rewritten it exactly as it is with 2 little changes. First one is the factoring we just talked about. The last denominator is now in factored form, x minus 2. The other thing is that I've given myself a lot of space in these fractions. And you guys remember when we had lots of space in the fractions, we put it there so we could fill things in, so we could make the denominators the same. And in fact, that's exactly our step here. So let us fill in and make all 3 of these denominators the same. What is this first fraction missing that the second fraction has? X minus 2. So we give this fraction an x minus 2, and right away we give the top of this fraction an x minus 2. For sure, we need parentheses around the x minus 2, and it's a good habit to put parentheses around the numerators as well. Sometimes you need them. Okay, take a look at the first 2 denominators. You agree they're the same? Great. Now we're ready to expand and include the third denominator. What does the third denominator have that the first 2 do not? X. So you give both of these denominators an x. Right, we're trying to complete and make these denominators the same. So the first fraction gets an x on top and bottom, parentheses around both. The second fraction also gets an x on top and bottom, which means putting lots of parentheses around that second fraction now. Is the third fraction missing anything from the first 2 fractions? No. All 3 of these denominators are now exactly the same, okay? All right, so here is the twist. Here's the difference between equation solving, which we're doing now today for the first time, and adding 2 fractions, which we've done before. Instead of combining and making a single fraction here, what we're going to do is we're going to multiply both sides of this equation by the lowest common denominator. So put big brackets around both of these things. And we're going to multiply both sides by that lowest common denominator. It doesn't matter what order you put it. I'll put x minus 2. Just for kicks, put it over 1 just so we really see it's on top. So we're multiplying the left-hand side by that thing, and we better at the same instant multiply the right-hand side by the same thing. And again, that's over a 1. And it's not clear why we're doing that, but at least it's legal, right? you buy that we can multiply both sides of any equation by anything, as long as it's the same thing on both sides. So we've done that. All right, and now we get the greatest cancellation in the history of algebra class. So take a look at the right-hand side first. Looking at multiplication of two fractions, yes? And yes, you could multiply straight across, but before we do that, we look to cancel. What can you cancel that's the same on top and on the bottom? X and x minus 2. And so we cancel them in one fell swoop. We're not multiplying. You're putting that x and x minus 2 there specifically for the purposes of canceling. So you don't do anything with it except put it there and right away cancel it. Left-hand side is slightly more complicated, but wonderful canceling is still going to happen. I'm going to write some stuff. You don't need to write this part. It's going to get kind of messy. First of all, inside these big brackets on the left-hand side is a plus sign. That means there's two terms in here. This thing right here distributes to both of those terms. Agree? I'm not going to write that out, but in my mind, that x minus 2, that orange thing, is next to the first fraction, and separately it's next to the second fraction. It is on both of the fractions. Let's imagine this thing here next to the first fraction. What cancels on the top and the bottom? X cancels here, and x minus 2 cancels there. So it disappears entirely on the first fraction and crosses off the denominator. But separately, that orange thing is next to the second fraction as well. So imagine it's sitting there right on top. What cancels with that orange thing in the denominator? The x and the x minus 2, right? They both cancel. And so I'm not going to write out that distributing, but I'm just going to gleefully cross off all of my denominators and the orange x minus 2 that I put there. And if you take a look, there are no denominators left except for a 1, which isn't anything, right? And so again, you put the lowest common denominator on both sides specifically for the purpose of canceling, and you put it and right away you get rid of it. Don't do any crazy thing like multiply that denominator through. I've seen this before where a student will say, okay, I need to distribute, let's see, that x, and I got this x minus 2 times another x minus 2, and then they'll start like multiplying lots of things out. It's not wrong, but you're missing the boat if you do that. Okay, so let's take a look at what remains. All I have are my numerators, so I'm going to squeeze it in here. I think 2x minus 2x plus, that's the plus sign between the fractions, 4 and x equals 8. Does everybody see where that came from? And we believe this equation is the best one on the page so far, right? Much better than any of the ones that we had before. This one has no fractions. Okay, we do need to get rid of these parentheses. I'm going to imagine, I'm just going to shuffle things around. The 2 and the x, I'm going to imagine that as being in the front. So that I can just do a single distributing property here. So we didn't distribute yet there, that's just shuffling around. So we'll distribute the 2x through, so we go 2x squared minus 4x, and then copy the plus 4x equals 8. All right, in this case, the 4x's cancel, so we're just left with 2x squared equals 8. And usually with quadratic equations, again, quadratic because there's an x squared, you would get one side to be what magic number? What's the magic number we want for quadratic equations on one side of the equals? 0, that's the magic number. But this is the one special case where it's actually easier to do another technique, not 0, but just get the x squared isolated. So if we divide both sides by 2, we get x squared equals 4. And then what do you do to both sides to get rid of that square? Find the square root. And so we square root both sides. So I'm going to actually just write it, x squared equals 4. But then I'll put a square root. I'm inserting that square root in the front of both sides. But don't forget, when you take the square root of both sides, what do you need to put in? Plus or minus. So we'll put that on the right-hand side. And so I think this one is basically done now. Square root of x squared, that's just x, equals plus or minus square root of 4 happens to be a nice number. It's 2. So we have 2 solutions. Remember I said at the start here, the answers to the problems from this class are different from the last 3 classes. The answers today are x equals some number or a couple of different numbers in this case. Okay, oftentimes in algebra class, once you get the value or values of x, you stop, you're done. And the check is an optional thing, right? I haven't forced you to do any checks on any of the tests or quests this semester. Sometimes it's in the homework. But the check typically is really just to make sure you didn't goof and make a mistake, and if you did, to catch it and know that you're supposed to go back and fix it. Well, it turns out that the checking here for these kinds of equations, where there's x's in the denominators, is actually not optional. It is mandatory. And let's see why. We got 2 answers to check. Let's go back up to this original equation. We're going to check our answers one at a time here. I'm going to start by checking x equals -2, right? We had +2 and we had -2. Let's start with x equals -2. And we're plugging it into this original equation here. So it goes 2 plus 4 over. Now if x is -2, how much is this denominator? X is -2. Is -4, right? -2 minus 2 more. So -4 there. I'm going to put an equals with a question mark because we're checking. And what I'm saying here is that we actually do have to check and see if it works. On the right-hand side, 8 over, this one's a little more complicated. I'll just write it's -2 squared minus 2 times -2. That is replacing both of those x's with a -2. Okay, let's keep checking here. 2 plus, how much is 4 over -4? Over -4, -1, equals, still with a question mark, 8 over, all right, let's do the arithmetic carefully here. Is this -2 squared positive or -4? That's +4. How about over here? Plus or -4? That's also plus because it's a minus and a minus, right? So it's 4 plus 4, which is 8. Yes? Just being very careful with the signs. Okay, is this equation true or false? It's true. Left-hand side is 2 plus -1. That's just 1. The right-hand side, 8 over 8. That's also 1. So the equation works. And you're not surprised. We did all the algebra correctly. We got x equals -2 as an answer. Not surprisingly, yes, of course it works. That's the point of algebras. You find answers to equations, solutions to equations. Okay, so here's the bad part. Let's try the same thing over here with x equals 2. I'm plugging into, again, this original yellow equation. 2 plus 4 over x is now becoming 2, I'll just put it there, equals question mark. Both of these x's are becoming 2's. Just like that. So have I replaced all the x's with 2? I have. What can you tell me about that 4 over 2 minus 2? Zero in the denominator. This is 4 divided by 0. What do we call fractions with 0 in the denominator? Starting with a u. Undefined. That is undefined. That's it. It's not equal to anything. I mean, I don't even need to check anymore. If you look at the right-hand side, what is that denominator? That's also a 0. It's also undefined, but you can't say, 2 plus something undefined is equal to undefined. It works. Like, it doesn't work. As soon as you get something undefined, the x value is just not a solution. So I'm going to reject x equals 2. It simply doesn't work. And this is really discouraging because typically if you get something that looks like a solution but isn't, it means you made a mistake. Well, we didn't make any mistakes here. But this is just the nature of these kinds of equations. Equations with x's in the denominator, sometimes this happens. And so you're checking here not to catch errors on your part, although it might do that sometimes, but to actually see if the thing is really a solution. So in this case, x equals -2 works, x equals +2 does not work. Any questions on that? That's right. And so you could just simply cross off the x equals 2 and circle x equals -2. Not looking for a lot of words here, but I'm looking to see that you checked to see that whether or not you had a solution. Okay, so here's a shortcut. It turns out you don't actually need to do the full-fledged check to figure out whether or not what you have is a solution. All you need to be on the lookout for is what happened here in blue, where you had something undefined. That is the only way that something is going to fail to be a solution. Over here on the green, as soon as I saw that I didn't have zeros in my denominators, I didn't need to go any farther. It's going to work every time. The thing will be a solution. Okay, so here's your shortcut now. If you get values of x, all you do is plug them into your denominators. If you get undefined fractions, you reject them. But as soon as you see that those fractions are not undefined, you stop and you say, this is going to be a solution, okay? So for example, the activity here on the next page, I'm just going to make up a number here. You're going to solve these in just a few minutes. But suppose that I tell you that x equals 3 and x equals -2. Suppose that those turn out to be the two things that you get when you solve this. You're going to do it on your own. Let's see if they are solutions. What I'm telling you have to do is not go through the whole check, but just plug into the denominators and look to see if you get 0. If you plug 3 right there, what do you get on the bottom? 10. I don't need to do anything more. X equals 3 is going to work. It's going to be a solution. All I'm looking for is 0 or not 0. It's a simple test, okay? As soon as you see it's not 0, you say there's no problems, nothing undefined. X equals 3 is going to work. Now suppose that you do x equals -2. What do you get in that denominator? You get 0, right? 2 times -2 plus 4. And as soon as you get 0, you reject x equals -2. You don't need to plug in anywhere else. Just looking for undefined or not. That's our check. Okay, so it's not a full-fledged check.